let's have a look at different ways of displaying data. So here are some of the common ones. So for example, a stem and leaf plot. So I've got two types here, a summary and a comparison example. So in a stem and leaf graph, we have a stem down the side, and then we have the leaves, like the branches on the tree. Now, if I had, for example, if I take this first row, okay, there are actually two data values there. There is the data value 122 and the data value 126. And so what we've done is we've taken that stem of 12 and then we've added a leaf of 2 to one of them, the same stem of 12 and a leaf of 6 to the other. And if I was to do this last row there are two data values there. I do the 18 and it's got a leaf of 1 and the stem of 18 and a leaf of 3. So that's our stem and leaf graph, and it's a very common one for people that are using, if they're out and about and don't have access to a calculator and computer easily, and are just recording data by hand. It's quite a useful one to collect data with. In the comparison example, you've actually got the stem down the middle. Okay, so the stem is in the middle section. So I'm comparing this group, the males with the females, and for example, I've got a stem there of 1. So I'm going to take that 1, and on the female side, that would be a value of 15 and a value of 18. On the male side, we would have 15, 12, and 10. So it's taking the stem with each of those leaf values. Another type is our bar graph. And if I'm just doing a summary graph, then for example here I've got mangoes versus apples versus grapes versus bananas versus oranges. And it wouldn't matter whether it's whether the graphs are in this up and down pattern or whether they're turned side by side. Okay, same thing, you've just got one set of information that you're plotting, which is about the fruits. If I was to do a comparison bar graph, and you can see there we've got the light blue, which is the United States, and the red, which is the United Kingdom, and often we'll do a side by side, and that gives you a way to nicely compare those different things. Now there's a difference between a bar graph and a histogram. Now particularly if you go back to, if we just have a look back at these graphs here, in the bar graph I had fruit options: mangoes, apples, grapes, bananas, oranges. Those are all separate things, and that's why when we draw the graph there is space between the bars that they don't touch. However, with a histogram is when you've got, so this is your bar graph is discrete data, whereas a histogram is your continuous or your measurement data. So that's why if I'm looking at the age group, the first age group goes from 0 to 5, and then the next one goes from 6 to 10, and that's because literally somebody can be 5 years old, 11 months, 30 days, etc., and then the person that's one more day older than them is on the next category. So these categories go right up to each other, and that's why they're joined together. So you've got the summary on the left hand side, and on the right hand side we've got a comparison, and that's where often we'll use two different colours to show two different things. A dot plot, and so on a dot plot we're now dealing with numbers. Okay, you can see on the axis there, that's just your standard number line, and each dot represents a particular piece of data. So if I look at, for example, the zeros, each of those dots represents a data that we've collected of zeros. Okay, whereas at the end there we've got one data of 12, so that would be a data value of 12, and I've got 1, 2, 3, 4 dots at 11, so that means I would have 11, 4 lots of 11. Okay, comparison dot plot, we would, for example, comparing the boys with the girls, and so that's when we would compare them one on top of each other, like it is in that graph. A box and whisker graph is a summary of that, so it takes your dot plot and provides a summary of that. And equally, if you've got a comparison one, you've got your two groups, and we compare them one above each other. With a scatter plot, Okay, what we've got now is I've got, for example, husband's age versus wife's age, and these are our standard XY, and each dot represents a couple, and that's their husband's age and wife's age in that couple. So it could be that I've got a person up here at the very top here where the husband is 78 years old perhaps, and the wife is 82 years old perhaps. And so that gives us, so each of these data values represents two pieces of information. And a comparison one, we would use colour or different symbols to represent that. Line graphs, so that's when we have got a bunch of data that is connected together with lines, and comparison would just be the two different colour lines. And the last one is our time series. So in terms of time series, the x-axis is always to do with time. It could be in months, it could be in years, it could be in days of the week, could be in hours of the day. Whatever the other data is about, one of the axes is always about time.